we're coming up with, but a final presentation now. And this is from another Jez. Here we go, Jez Parker, and from Mike Wild there from MW Polymers. This is for me, I'm not going to say no tech, a simple tech solution to a real issue. Call it, I think, but go ahead. Over to you, Jez and Mike.
I can't hear a thing.
You're on mute, Jez.
Hello, can you hear me?
Hello,
Yep.
Good afternoon. Can everybody hear me?
We can.
Okay,
Yes,
so
we can,
my name's Jez Parker, and joining me on the presentation this afternoon is the founder of MW Polymers and managing director, Mike Wild. So today we're presenting the Aqua-tite water clamp, an easy fit, cost-effective repair solution for the water industry. Could I have the next slide, please? Could I have a slide? Thank you. So MW Polymers have been manufacturing leak sealing products, mainly for the gas industry, for the last 40 years. We also have experience of sealing liquids in the chemical and food industries, and we develop unique solutions that are manufactured in-house using our own resin formulations, some of which are patented. Our systems are approved to a technical performance standard, including a 50-year life test. And our global customer base includes all the UK gas utilities, as well as customers across Europe, Asia, Australasia, including the likes of Hong Kong and China Gas and New Zealand gas company, Electrics. And the next slide, please. So to establish the features required in a design for a better water leak repair method, we looked at the extent of the problem. Our latest research of the water industry revealed in a UK survey there were 48,000 kilometres of pipe that had 78,000 water leaks. Most were on pipes of 250 millimetres diameter or less, and of these 78,000 leaks, 60,000 were circumferential breaks and 18,000 corrosion holes. So that gives us some idea that we need to create a clamp for pipe breakages and pinhole corrosion. So if you'd like to go to slide 4, and Mike will take you through the product itself. Thank you.
Okay, hope you can hear me. Yes?
Yes.
Okay, so hello everybody, I'm Mike Wild, and during our 40 years of sealing gas leaks, we know from the sites that we visit that and carry out repairs that the conventional clamps, the kind of thing you see on the right hand side there, will only tolerate a relatively small amount of leakage or ground part displacement. The leakage that you're looking at on the other pictures there tends to really, what we imagine in the gas industry, when you've got water leakage like that, it actually washes away the ground. So you guys in the water have got a benefit of having the excavation started for you. In the gas industry, it doesn't quite work like that. If the broken ends of the pipe are badly misaligned, as in a typical ground movement, then they provide the seal to have a clamp that realigns the pipe, as you see on the right hand side there. The clamps tend to build back into the stress that caused the breakages in the first place. And our first objective was therefore to create a clamp for the water industry with a greater angular deflection to the conventional clamps that would seal at live pressure and did not require the broken ends of the pipe to be realigned. Can you have the next slide, please? So there you see the kind of thing that we've developed, and it's the principle of that, our Aqua-tite system. And we incorporate a reinforcement into the hard molded polymer half shell, creating an accurate but economic 3D manufacturing method. The shells are bolted together and form a loose fit around the pipe, and then we can cater up to 20 degrees movement of misalignment. Built into each half shell is a rubber membrane. The shell body has a hole through to the inner rubber lining, and a settable resin is injected from a hand-operated dispenser into the shell that displaces the rubber lining to squeeze the rubber and gently but firmly form an exact profile of the pipe that stops the leakage. Within a few minutes, the resin cures to a tough but flexible solid polymer, holding the pipe pressure without placing undue pressure on the pipe system. Next slide, please. Okay, so here you see what we've carried out as a repair, and then we've cut the thing in half. So we've got a loose fit clamp, which means that you've got a wider range of clamps. It copes with ovality, corrosion, and misalignment, high amounts of misalignment. The inner sleeve is filled with this settable resin, which you can see as the white material that deforms the rubber lining and provides the exact profile to give a seal to the broken pipe. This resin cures to an exact fit. The result is a robust sealing system that remains under pressure without building stress back into the pipe system. Next slide, please. So what we've shown here is examples of the pinhole corrosion that we were asked, could we repair these? Could we provide a sealing method for these without stopping the leak, without doing anything? And the answer to that was yes. We had a video inclusion within our presentation, which was a minute long, and we felt that it was just a little bit too lengthy. It was a little bit too long, so we took it out. So we can show that, and it shows how this exact type of leak is sealed with using this method. Next slide, please. Okay, so in summary then, what we have is Aqua-tite, which tolerates angular ground misalignment, corrosion pitting and pipe ovality by injecting a settable resin between the clamp and the rubber sleeve. Our method does not put the stress back into the pipe system. The resin clamp will not corrode. The injected liquid does not come into contact with the leaking water. Next slide, please. Here you can see, using our Aqua-tite technology, we can produce a variety of different leaking requirements. What we're showing there is a 90-degree elbow. We 3D print these, make them in resin, line them with a rubber lining on the inside, so we can cope with a variety of different shapes and sizes. I think in summary, and this is my last bit before Jez takes back over, but in summary, we're able to deal with the nightmare water problem scenarios that Jez was talking about earlier on. They're the sort of things that are our bread and butter within the gas industry, and we hope that we can bring that kind of technology and that experience, 40 years of experience, into the water industry. Okay, thank you. Next slide.
Okay, thanks, Mike. So yeah, just to round off, we just wanted to say that we are making lots of you guys aware of our latest innovation, and we're actually looking for a partner to drive this innovation forward. So we'd be pleased to hear from anybody that would like to form a partnership. So that concludes our presentation today. Thank you very much.
Thank you, and a great timing as well, but we've got time for some Q&A, I think, before we kind of run into the major Q&A sessions. So just relating to that particular one. So really interesting, and I like that, this kind of this filler that you've got coming in, this resin that comes in behind it kind of effectively provides a custom joint around it. If we had a gap there, so sometimes you find not only do pipes kind of shift, but they may also pull. Have you looked at all on how large a gap you'd be able to bridge with this system?
Okay, shall I answer that one, Jez? Yeah, yes. What we've done there is, within the gas industry knowledge that we know, we generally would look at the amount of gas leakage with a pipe displacement. But from our understanding, you could really cope with, because the sleeve is loose. you could cope with thousands of litres a minute. And there's no real issue with that. It can, we designed it to cope with high volumes of leakage. If you're trying to get a sleeve to fit closely around the pipe to start with, we encountered problems with the amount of leakage and pressure of water. But if you make it very loose and then inflate the pipe down onto, inflate the sleeve down onto the pipe, it's a very simple process. And you would have seen that if you would have got the video.
And then secondly, in terms of materials side, what materials would you recommend this for?
The materials that we use are basically polyurethanes, can be epoxies, and we might be. Sorry,
I meant what pipe materials, Mike?
Well,
pipe materials?
Polyethylene, ductile iron, anything like that. The way in which the technique grips the pipe gently, we're using this within the gas industry to repair damaged polyethylene. And what it does is it tends to very gently squeeze the PE. If you get a pipe clamp that's too strong with too much compressive stress, it actually extrudes the PE from under the pipe. So we know, and the leak tends to return. Whereas this technique, it just doesn't do that.
Guy, I've just seen your comment there on Guy has asked, does this make things repairable that might otherwise need a cutout? And that's exactly what I was looking at it for. That's where I think that there's great benefit, but I think there's even more than that because of this ability to kind of customize a fit around something. You can imagine that being used on kind of flat flanges, anything else. I think this is a kind of technology that potentially could be expanded into other areas. Okay, look, that's really great. Thank you so much to Mike and to Jez for taking us through that. If everybody just stays online now, because what we're going to do is kind of go into a wider discussion session.